Hello, in this tutorial, we are going to discuss the multiplication of two complex numbers in polar form. Now, we are going to assume two complex numbers. Let's assume the first complex number to be Z1. Now, we know that we are considering the multiplication of complex numbers in their polar form. A complex number that is not in its polar form, that is, the general representation is Z is equal to A plus IB. So, but when this now is in its polar form, we have Z to be equal to, we express it in terms of the length of the complex number and the angle of inclination. So, which will be R into cos theta plus I sine theta. So, it means that if we are to attribute Z1 is going to go along with the length of Z1, which will be R1. Then the angle of inclination for that complex number, which will be what? Theta 1. So Z1 here is going to give us R1 into cos theta 1 plus I sine theta 1. We'll call this equation 1. Now, same thing. If we attribute Z2, because we want to consider the multiplication of two complex numbers, our Z2 will now give us what? R2 into cos theta 2 plus I sine theta 2. Now we'll call this equation 2. Now, Z1 times Z2 is going to give us the multiplication of R1 cos theta 1 plus I sine theta 1 multiplied by R2 cos theta 2 plus I sine theta 2. Now, Z1 times Z2 is going to give us R1 can multiply R2 here. So it means that we can start with saying R1 times R2 into the multiplication of cos theta 1 plus I sine theta 1 multiplied by cos theta 2 plus I sine theta 2. Now, the reason is because if we say, why is this equation the same thing as this? Let's assume that we have to solve 2 multiplied by 3 times 3 multiplied by, let's say, 6. Here I'm signifying R1 as 2 and our R2 as 3. Okay, or let me make it more similar. Let me say 2 times 2 plus 1 times 3 times 1 plus 2. So I want to make it very similar. What we did here was that we multiplied this 2 by this 3, which is giving us 2 times 3, before we now have 2 plus 1 times 1 plus 2. Here, this will give us 6 into 2 plus 1 is 3 times 1 plus 2 is 3. This is 6 times 9, which will give us what? 54. Now, if we consider it from here, 2 times 2 plus 1, which is what? 3 times 3 times 1 plus 2, which is also what? 3. 3 times 3 times 3 will give us 27. 27 times 2 will still give us the same value as what? 54. So that is why R1 times, you can use this R1 to multiply this R2 before you now use what is inside bracket to multiply each other. So now let's continue. From here, Z1 times Z2 will give us R1, R2. Then we use this to open the bracket. Cos theta 1 into cos theta 2 plus I sine theta 2 Then we use I sine theta 1 also to open the bracket. I sine theta 1 into cos theta 2 plus I sine theta 2. Now, it means that Z1 times Z2 is going to give us R1, R2 into cos theta 1 times cos theta 2 is going to give us cos theta 1, cos theta 2. Cos theta 1, cos theta 2 plus cos theta 1 times I sine theta 2 will give us I cos theta 1 sine theta 2 plus I sine theta 1 plus times cos theta 2. That will give us I cos theta 2 sine theta 1 plus I times I. This is going to give us what? I square. Sine theta 1 times sine theta 2. That will give us sine theta 1 sine theta 2. So here, Z1, Z2 is going to give us what? R1, R2, open bracket, cos theta 1, cos theta 2 plus I cos theta 1 sine theta 2 plus I cos theta 2 sine theta 1 plus, now I square is what? Minus 1. So instead of writing this plus, we can just put minus. So this will be minus sine theta 1 sine theta 2. Now here, Z1 multiplied by Z2 will give us R1, R2 into, if we collect like terms, those that does not have an imaginary number, that is, we are adding the real parts to the real parts. This has I, this has I. So these are our the two imaginary parts. Why? Cos theta 1, this and the last one are the real parts. It doesn't have an imaginary number. So if we put cos theta 1, cos theta 2, then merging it with the last one, which is minus sine theta 1 sine theta 2. Now, the ones that have the imaginary parts, let's factorize I out. This will remain cos theta 1 sine theta 2 plus cos theta 2 sine theta 1. Now, it means that Z1, Z2 is going to give us R1, R2 into, now, as a remark, cos A plus B. Cos A plus B is the same thing as cos A cos B minus sine A sine B. So here, if our A is theta 1 and our B is theta 2, cos A, cos theta 1, cos theta 2 minus sine A, sine theta 1, sine theta 2 is going to give us what? Cos A plus B. And our theta 1 here is what? A. Our theta 2 here is what? B. So this statement, cos theta 1, cos theta 2 minus sine theta 1, sine theta 2 is going to give us cos theta 1 plus theta 2. Now, going to the imaginary part, we have cos theta 1 sine theta 2 plus cos theta 2 sine theta 1. Now, there is a trigonometric identity that also states that sine A plus B. What connects sine A plus B? Now, take a look at this. Sine A plus B is the same thing as sine A cos B plus cos A sine B. So sine A plus B is the same thing as sine A cos B plus cos A sine B. So it means that sine theta 1 plus theta 2, where our A is theta 1, theta 2. This will give us sine theta 1 cos what? Theta 2. Sine theta 1 cos theta 2. That's what we have here. Plus cos A sine B, cos theta 1 sine theta 2. Cos theta 1 sine theta 2. Are you getting the logic? Again, sine A plus B is sine A cos B plus cos A sine B. Now we are taking this A. Let me write this out here. We are taking our A to be theta 1, and we are taking our B to be what? Theta 2. So if our A is theta 2, it means that now this sine A, this will be what? Sine theta 1. This cos B, this will be what? Cos theta 2. Sine theta 1 cos theta 2 is the same thing as cos theta 2 sine theta 1, what we have here. Now, if we take the second one, cos A sine B, cos theta 1 sine theta 2, cos theta 1 sine theta 2. So it means that this, after writing I, cos theta 1 sine theta 2 plus cos theta 2 sine theta 1 is the same thing as sine theta 1 plus what? Theta 2. So basically, this is the general form for the multiplication of two complex numbers. That is, when you are given two complex numbers in polar form, the product of Z1 and Z2 is going to be the product of their two lengths. Then you open your bracket, cos theta 1 plus theta 2, the summation of the two angles of inclination with reference to cos, then plus I sine theta 1 plus theta 2, which is going to make your calculation very much simpler. Now, let's apply this in an example so that you get the concept very properly. Let's assume two complex numbers, or let's say that we have to multiply these two complex numbers that I'm going to give you now in polar form. If the first complex number is Z1 is equal to 2 into cos 30 plus I sine 30, and our Z2 is 3 into cos 40 plus I sine 40. Now, from this question, what it means is that our R1 is what? 2. Our theta 1 is what? 30. Our R2 here is what? 3. Our theta 2 is what? 40. Now, we have derived that Z1, Z2 is equivalent to R1, R2, open bracket, cos theta 1 plus theta 2 plus I sine theta 1 plus theta 2, close the bracket. So our Z1 times Z2 here will give us R1 times R2, that is what? 2 times 3. 2 times 3. Open bracket, cos, so sorry, this is a cos, open bracket this. Now theta 1 is 30, theta 2 is 40. So this will be what? Cos 30 plus what? 40 plus I sine 30 plus what? 40. So it means that Z1 times Z2 will give us 2 times 3 here will give us 6, open bracket, cos 70 plus I sine what? Sine 70. So this will be the final answer to that question. So our Z1, Z2, okay? Don't let those brackets confuse you. So this is just 6 into cos 70 plus I sine 70. So, and this makes it very much easier. For example, if you are solving these as objective questions, all you need to know is the condition that connects the product of two complex numbers in their polar form, which is Z1, Z2 is equal to R1, R2, open brackets, cos theta 1 plus theta 2 plus I sine theta 1 sine theta 2. Now, what also happens when we consider the division of two complex numbers also in their polar form? Now, using the same concept, if we are to consider the complex numbers Z1 and Z2, now just going straight into it now, our Z1 in the polar form is going to give us R1 into cos theta 1 plus I sine theta 1, while our Z2 will give us R2 cos theta 2 plus I sine theta 2. Now the division of this is going to give us z1 over z2. z1 over z2 give us r1 into cos theta 1 plus I sine theta 1 divided by r2 cos theta 2 plus I sine theta 2. Now here, what we are now going to do is that, of course, we know that when we are dealing with division, basically we are always trying to rationalize. So we are going to rationalize the denominator of these of these two polar forms that are slotted into the numerator and denominator. Now, if we are to rationalize using the concept of rationalization, we have to multiply the numerator and denominator by what? Conjugate of the denominator. Conjugate of this denominator will be cos theta 2 minus I sine theta 2. Now, we don't need to multiply by r1 and r2 because we are trying just to eliminate this. It's as if we want to try and eliminate the fractional form. So here, z1 over z2 is going to give us r1 over r2. Then let me use a combined, okay, before you say a combined bracket, let me just say times. We have cos theta 1 plus I sine theta 1. So divided by cos theta 2 plus I sine theta 2. If we rationalize here, this will be multiplied by conjugate of this is what? Cos theta 2 minus I sine theta 2. Everything is now being divided by the same thing, cos theta 2 minus I sine theta 2. Now, from here, our z1 over z2 is now going to give us r1 over r2 multiplied by, now we open the brackets. I'll use cos theta 1 to multiply first. So we have cos theta 1 into cos theta 2 minus I sine theta 2 plus I sine theta 1 into cos theta 2 minus I sine theta 2. So we now have everything being divided by, using this also to multiply, cos theta 2 plus I sine theta 2 times cos theta 2 minus I sine theta 2. That's difference of 2 squared. Don't forget. And that is going to, when we multiply A plus IB multiplied by A minus IB, what we are supposed to get is what? A square plus what? Plus B square. So it means that the denominator here, our A here is cos theta 2. So this will give us cos theta 2 square plus sine theta 2 square. So everything at the denominator here is going to give us this. Z1 over Z2 is going to give us R1 over R2 times cos theta 1 times cos theta 2 is going to give us cos theta 1 cos theta 2 minus cos theta 1 times I sine theta 2 will give us I cos theta 1 sine theta 2. So after we have multiplied cos theta 1 and minus I sine theta 2, that gave us minus I cos theta 1 sine theta 2 plus, now I sine theta 1 times cos theta 2 will give us I sine theta 1 cos theta 2 cos theta 2. Then plus I sine theta 1 times minus I sine theta 2 will give us minus I square sine theta 1 sine theta 2. Now everything here is going to be divided by cos square theta 2 plus sine square theta 2. Now don't forget, from trigonometrical identity, sine square theta plus cos square theta is equivalent to 1. So it means that cos square theta 2 plus sine square theta 2 is the same thing as sine square theta 2 plus cos square theta 2, which will eventually give us what? 1. So from here, our Z1 over Z2 is going to give us R1 over R2 multiplied by cos theta 1 cos theta 2, collecting like terms. Now, minus I square, okay, before we collect like terms, if we factorize I out of this will be plus I into minus cos theta 1 sine theta 2 plus sine theta 1 cos theta 2, close the bracket. Now I square is minus 1, so minus 1, this will give us plus sine theta 1 sine theta 2. So here our Z1 over Z2 is going to give us R1 over R2 multiplied by, collecting like terms, we are going to have cos theta 1 cos theta 2 plus sine theta 1 sine theta 2 plus I into, if I make the positive sign to come first, this will be sine theta 1 cos theta 2 minus cos theta 1 sine theta 2, close the bracket. Now from here, this is going to give us Z1 over Z2 is equal to R1 over R2 times, open brackets, now cos A minus B is the same thing as cos A minus B is the same thing as cos A cos B plus sine A sine B. Why? For our sine, when we are considering sine A minus sine B, our sine A minus sine B is going to give us what? Sine A minus B is going to give us what? Sine A cos B minus cos A sine B. So take a look at this. Cos A cos B cos theta 1 cos theta 2 plus sine A sine B sine theta 1 sine theta 2 is going to give us what? Cos A minus B, which is cos theta 1 minus theta 2 plus I into sine theta 1 cos theta 2 sine A cos B, our A is theta 1, our B is theta 2, minus cos theta 1 sine theta 2 cos A sine B is going to give us what? Sine A minus B. So this will give us sine theta 1 minus theta 2. So it means that the general representation for division of two complex numbers in their polar form is Z1 over Z2, which is the division of the two complex numbers in the polar form, is going to give us R1 over R2, open brackets, cos theta 1 minus theta 2 plus I sine theta 1 minus sine theta 2. So now let's take an example to prove that. So we have to evaluate 6 open bracket cos 72 plus I sine 72. Everything is being divided by 2 cos 41 plus I sine 41. So we have derived the formula already to be Z1 over Z2 is equal to R1 over R2 open bracket cos theta 1 minus theta 2 plus I sine theta 1, sorry, not theta 2, I sine theta 1 minus theta 2. So here from this question, our R1 is what? 6. Our R2 is what? Our R2 is 2. Our theta 1 is 72. Our theta 2 is 41. So substituting Z1 over Z2 here is going to give us 6 divided by 2 into cos 72 minus 41 plus I sine 72 minus 41. Close the bracket. So Z1 over Z2 is going to give us 6 divided by 2 is 3 into cos 72 minus 41. That is going to give us 31. So that will be cos 31 plus I sine 31. And that is going to be the division of these two complex numbers. So with this tutorial, you should be able to solve the multiplication of two complex numbers in their polar form and the division of two complex numbers in their polar form. See you in the next tutorial.